Welcome to The Explainer. Today, we're diving into what was honestly an absolutely unprecedented month in American energy innovation. We're looking at a moment where the U.S. nuclear sector pivoted from decades of notorious stagnation to breakneck, breathtaking speed. If you thought nuclear power was all about blown budgets and 30-year construction timelines, well, you're about to see how a handful of startups completely flipped the script. All right, let's just start with a staggering number: 8. 8 months. That is literally all it took for a company called Aalo to go from breaking ground on an empty dirt lot to achieving a sustained nuclear chain reaction. In an industry where progress has historically been measured in decades, this single metric represents one of the fastest reactor builds in modern American history. And that really begs the ultimate question we're tackling in this explainer today. How on earth did a historically sluggish industry suddenly deliver not one, not two, but 4 distinct advanced microreactors in a matter of mere weeks? How did these private startups move from clean sheet designs to major technical milestones so incredibly fast? Let's break it all down. Part 1. The impossible deadline. So the spark for all of this was Executive Order 14301, which was signed back in May 2025. This directive set what honestly seemed like a completely impossible goal for the country's 250th birthday. It mandated that at least 3 advanced test reactors achieve criticality, which is the point where a fission chain reaction becomes self-sustaining, by July 4th, 2026. The government was basically asking for 3 brand new reactors to hit this mark in essentially a year. Yasser Arafat, the president and CTO over at Aalo, hit the nail on the head here. He pointed out that the real challenge was never the science. I mean, we know the physics, right? The problem was that America had simply forgotten how to execute. They had to overcome a recent history defined by regulatory red tape, endless delays, and companies that promised the moon but just couldn't deliver. Section 2, the regulatory hack. To meet that crazy aggressive July 4th timeline, developers knew right away they couldn't just use the standard playbook. The traditional Nuclear Regulatory Commission, the NRC, their licensing process is notorious for taking years and sucking up massive amounts of capital just to get out of the gate. The alternative? A completely new, agile authorization pathway through the Department of Energy. This was a startup-friendly, incredibly accelerated route. The crucial takeaway here is that they leveraged the DOE's own site authorization authority. By utilizing initiatives like the DOE Reactor Pilot Program and the Nuclear Energy Launchpad over at the Idaho National Laboratory, these really nimble startups were able to bypass the NRC bottleneck entirely. This executive choice basically released a massive regulatory pressure valve, allowing them to rapidly greenlight their safety analyses and start testing real hardware safely and incredibly fast. Part 3. A 30-day sprint. Releasing that pressure kicked off a historic sprint. What happened between June 4th and July 4th was just a breathtaking race. Antares Nuclear crossed the line first with their Mark 0 reactor on June 4th. Then, just 2 weeks later, Valar achieved criticality with the Ward 250 out in Utah. June 30th, Deployable Energy's Unity reactor hits the mark. And finally, in the early morning hours of July 4th, Aalo brought the Aalo X online. 4 different companies, completely shattering the executive order's target of 3. I absolutely love this quote from Jordan Bramble, the CEO of Antares Nuclear. He said, "It's been a marathon where you're sprinting." And that perfectly captures the relentless, high-stakes energy of taking a clean sheet design all the way to a live, zero-power reactor test in less than a year. It's a pace that is completely unmatched in the modern advanced reactor era. Section 4. 4 unique designs. Now, what's really fascinating about this is that the US government didn't just pick one single design and copy-paste it 4 times. Instead, it was a diversified portfolio of technological bets. Antares used a sodium heat pipe design. Valar went with helium-cooled TRISO fuel, which uses these highly robust ceramic pellets. Deployable used a water-moderated gas-cooled approach, and Aalo utilized a sodium-cooled design. Developing these 4 distinct architectural approaches in parallel was a brilliant way to spread out the technical risk. Just take a moment to think about the beautiful complexity of the Aalo X design. When you consider its highly engineered, compact mechanical core, you instantly grasp what a massive physical shift this is for the industry. We are moving so far away from those giant, sprawling concrete cooling towers of the 20th century and moving toward factory-built, precision-engineered microreactors. Part 5. Powering the AI boom. So why does this compressed timeline matter? And where is all this power actually going? Well, the immediate commercial and defense applications are massive. Get this, on July 1st, Valar literally used its reactor's output to power an NVIDIA Blackwell AI system live on stage. They're already exploring a 30-megawatt AI data center in Utah. And over on the defense side, the Pentagon's Janus program is aggressively pushing to deploy these resilient, off-grid military reactors by September 2028. The biggest players in tech and defense are actively aligning their infrastructure with these startups right now. All of this leads us to a radically new business model. We're talking about clustering 10-megawatt units into 50-megawatt pods for AI data centers. So instead of spending 10 years and billions of dollars building one custom utility-scale plant tied to the public grid, data center operators can just assemble capacity from identical factory-built units placed directly behind the meter. It basically acts as a dedicated independent power grid specifically for hyperscale AI processing. Section 6. The New Nuclear Era. Looking at the aftermath of this 30-day sprint, the roadmap ahead is clear and it is incredibly aggressive. Step 1 was this summer, proving the zero-power physics and the supply chains in 2026. Step 2, that's transitioning these successful tests into actual commercial-scale electricity-producing prototypes next year in 2027. And then step 3 is establishing assembly line manufacturing for mass deployment by 2028. They are moving from design physics to operating fact in absolute record time. But, to keep this momentum going, there is definitely a looming battle. Crucially, companies like Valar are now legally challenging the NRC's jurisdiction over these microreactors. They are fighting tooth and nail to ensure that this fast-track, agile DOE pathway remains open, not just for these initial tests, but for full commercial rollouts. Because if they get forced back into the traditional NRC pipeline, this multi-month schedule could very easily revert back to a multi-year slog. Which brings us to the final thought I want to leave you with as we wrap up this explainer. With agile startups clearly proving that they can deliver factory-built diverse microreactors in a matter of months rather than decades, will we ever build a traditional massive nuclear megaproject again? Or have these 4 startups, in a single 30-day sprint, just permanently rewritten the future of American power? It is a fascinating shift, and we will definitely be watching closely to see what happens in 2027.